Hello everyone, welcome to the P1 program. This lecture is called P104.3. This is the third part of the lecture. In this lecture, we are going to discuss about transformations, coordinate transformations in a bit more detail. Okay, last time we have mentioned some transformations like you transform from x and y to r and theta. That's a transformation of polar coordinates. Now you transformed xyc into r theta phi, right? That was spherical polar. We also did cylindrical, and we can do much more just like that. This is kind of a transformation where you fix a point fix a point in space, and then you transform the space around it. Now what I'm going to introduce next is something a bit more different. Okay, so if you consider a football field, right, and there is two uh, goalposts. There are two goalposts, and you are standing here. Okay, you are standing here. You are a person standing over here. Now, if you need to represent the position from, say, goalpost, the vector you can draw, and it will be some distance, right? Some distance, say d. Also, if you have a different point from here, and you can draw another distance, say d2, you know that the d and d2 are going to be the same for only one point, right? If you rotate this point to either directions, this vector to either directions, you won't get the same point, right? And the distance will change. Okay, distance will change. It will only meet at one point. Two lines meet at one point at a specific distance. Okay, and that's one thing. So what it denotes is that in two dimension you need two things to represent any position or any location. Okay, two things. It can be it can be xy, a coordinate system. It can be d1 d2, two distances. It can be theta 1 theta 2, two angles of some line. It can be anything, but it has to be two. So going backwards, you can clearly say that if you have an origin and you have a point here, say x, and this point is at a particular distance from the origin. So if it's 10, then you clearly know what the point is. So you only require one factor, say r or x or something like that, some distance to represent a point in one dimension, right? Now coming into three dimensions, we discussed three dimensions, two dimensions, and one dimension. So in three dimensions, you will require 3 points. So it can be x, y, z. It can be r theta phi, as we have discussed earlier. It can be some two distance and an angle. It can be two angle and a distance. Doesn't matter, but it has to be three. Okay, so it has, in three dimensions, everything has to be specified in three. That's the basic thing. Okay, I just wanted to make you aware of that. Now coming back to the football stadium. Okay, back to the football stadium, where you know the location of a person. If I'm standing here using two constraints or two coordinates, two things. Okay, using two things, you know the location. Okay, you know the location, and you draw a line, right? You draw a vector based on that location. Now if someone asks you, uh, they want to know the same thing from another location, say this location, what would you do? Okay, that's another thing. They want to find out the vector, the second vector from the new location. Okay, what would be that vector? Now for that you need to have some connection, so you need to connect between these two lines and to see what the relation is. Okay, that is also a coordinate transformation. So I'm not going to explain much further. Anyway, let's get to the point. So if you have a coordinate system like this, say x and y, and I shift the coordinate system to the right in the x-axis, and the new coordinate system will become x dash and y dash, right? So the new coordinate system has a difference of, say, c. So what has happened in the equation is that x has become, or x dash has become x plus c. Y dash will be the same, it will be y itself, because there is no change in y axis. So similarly, if you look at two coordinates where the new coordinate is like this, okay, this like this, then the equation will become x dash will be x itself, y dash will be y plus some constant c. Okay, this was the c. Now if you look at a third thing, if you have a coordinate system like that, x and y, a new coordinate system like this, x dash and y dash, you can clearly see that there is an intercept change in the new coordinate system on both an x and y, right? So this will be some constant c, and this will also be c, let it be c. Okay, if that's the case, then you can write down the equation as x dash will be equal to x plus c, and y dash will be equal to y plus c, right? That's how you transform a coordinate. That's a basic transformation. Now you can clearly see that all you have to do is you have to find the coordinate in the given vector. If this is the vector, the given vector in the x dash and y dash axis coordinate system, you need to find out what the value is and then substitute that into this equation, and you get the result. You get the coordinates of the vector in terms of x and y. So all you need to do is just that transformation. Okay, now what happens if we do this was the earlier coordinate system, and the new coordinate system is something like this. Okay, this is the new coordinate system. You see that there is an angle, say theta difference in the new coordinate system. So the coordinate system has become, say, x dash and y dash, and the old coordinate system was x and y, right? Now the coordinate system has changed with an angle. You have rotated the coordinate system. So if you look at this, you can see that the new coordinate system is itself become a vector in the old coordinate system. So you can decompose these components and say you can decompose as x dash of x, right? So let's rename it to something simpler, right? So you don't get confused. I don't want you to get confused, so I'm going to rename it as l and j. Okay, l and j, or okay, l and j, let it be l and j. So l has become as lx, which is the x intercept of l, and this is ly, which is y intercept. Okay, so you clearly see that if you take cos theta, you get, right, cos theta will be adjacent by hypotenuse, which is lx by magnitude of l, and also sin theta will be ly times magnitude of l, basic trigonometry. So you know lx has become l magnitude of l times cos theta, and ly has become magnitude of l times sin theta, right? So we have found out lx and ly. What about um, uh, j? Now j, if you look closely, you can see that the coordinate system, this angle will be 90 minus theta, right? 90 minus theta, 90 minus theta. Okay, that's the angle right there. So this angle has become 90 minus theta. So you see that if you draw an intercept like that, this length will be jx, and this will be jy, right? So this length is jx and this will be jy, right? And if you, this angle is 90 minus theta, Okay, let's redraw it, okay, as a easy one. This is 90 minus theta, and this is j, magnitude of j, this is jx and jy. So now cos 90 minus theta, which is equal to trigonometrically sin theta. So this will become cos theta is just adjacent by hypotenuse, it's jx by magnitude of j, right? So jx here is negative, okay, it's negative because it's going to the other direction. If it was this was taken as positive and this was also taken as negative, and the anything down is negative and this is also negative, if that was our case, then jx will be negative, so you write down a negative here, okay. So jxj, so you can write down that jx is equal to j sin theta with a minus sign, right? And also you can look at sin theta here. Sin theta is just opposite by hypotenuse, which is sine, it is actually sine 90 minus theta, right? So it's 90 minus theta, which is equal to cos theta. So that will be equal to opposite, which is jy by magnitude of j, okay. So you can say that jy is equal to j times cos theta. So you found out jx, you found out jy, okay, you found out that, and we have also found out lx and ly, right? So we got all that. Now what I'm going to do is, if I just divide, okay, if I divide 100 kilograms by 100, I'll get 1 kilogram, right? So if you divide 100 meters by 100, you get 1 meter. So whatever you divide, whatever value you divide with its magnitude, you get a unit value. So if you divide a vector r by its magnitude, you get a unit vector r cap, right? So that's a basic thing. So if you look at this equation, you can divide right hand side and left hand side. Lx is equal to L cos theta. You can divide the left hand side and the right hand side with the magnitude, and you get Lx, which is unit vector, and you get cos theta, right? So similarly, if you do all that, you get Ly cap, which is equal to sin theta, right? Sin theta, and you get jx, jx cap is equal to what was that, okay, minus sin theta, right? Minus sin theta, and L jy jy unit vector will be cos theta, right? Cos theta, okay. So that's it. Now with the unit vectors, okay, because this side is a vector, this side is also a vector. So this is x cap, y cap, and y cap, okay. So that's the vector that you will get. So we have found out what lx, ly, and lz, okay, the unit vectors in the new coordinate system is what we have found out. We have found out the new vectors, the L and J unit vectors. We knew x and y, right? We have transformed our system from x and y to lx, or x cap and y cap, to into lx and L and J system, okay, L and J system, okay. So we have transformed this into that, okay. That's what we have done. Now if you want to use it, you let's say you have a vector like this, okay, you have a vector like this, and you need to find out you know what it mean in L and J coordinate system, and you have this coordinate system, some kind of a coordinate system x and y. Okay, you have to transform the vector r in terms of this coordinate system. So for that you can use this equation. All you have to do is substitute this into the values of Lx and Ly. So basically you can write this down in terms of a matrix, right? You can write this down as, okay, a matrix form of Lx, Ly and Jy, right? You can write it down like that. So the x and y coordinate system has become that. Okay, so that's how you transform a system. Now how can you use it? You let's say that you have a matrix of 3 of L plus 4 J cap, right? That's the matrix that you have. Now you need, if you need to transform that into x and y, all you have to do is just multiply 3 and the components 3 and 4 with this matrix which is cos theta, sin theta, and then minus sin theta. There is x cap, and there is x cap, and there is y cap, and cos theta and y cap, right? Sorry about that. So all you have to do is multiply with that. You can multiply the row and column. You get 3 cos theta times x cap minus 4 sin theta x cap, right, plus 4 sin theta, sorry, 3 sin theta, the row and the column, next row and next column, y cap plus 4 cos theta y cap. So that's the matrix 3L and 4J in terms of x and y. So we have transformed 3L and 4J in terms of x and y using just this matrix. Okay, you remember, this matrix is called the rotational matrix. Okay, rotational matrix. So using the rotational matrix you can transform anything. You don't need to do all this. Okay, this is the a part of derivation that you don't need to do always when you are encountered with a problem. If you are doing a problem in real life, all you have to do is just substitute that values. So we have just transformed an equation. Now okay, let me tell it a different way, in a different way, okay, so that you will have some deeper understanding. So if you have a coordinate system like that and you have a transformed coordinate system like this, okay, this is the transformed coordinate system, and this coordinate system is called xy, and the new coordinate system is called j and L. Was it? Yes, it was L. So if you know the angle between these two coordinate system, and you know the distance or separation distance of this coordinate system, new coordinate system, you can easily transform. So you can say, let's call this 3 and 4, right? If it was 3 and 4, you know all this, and you need to find out the what this vector is in, vector r is in the coordinate system x and y. Okay, so if you have an equation, say the same equation 3L cap plus 4J cap, in that all you need to do is you can re and introduce this system as, say, x, the origin has now shifted, right? If the origin, say x0 is the origin, x0 has become x plus 3, and y0 has become y plus 4, right? Y plus 4. So you can now write down for x cap and y cap, these are vectors, right? So you can write down now that you can multiply this vector with the rotational matrix now, and all you have to do is all you have to do is to find out in terms of x, you have to do is you have to subtract 3x cap from the founded out value from this multiplication. From this multiplication you get this, right? You get 3 cos theta x cap minus 4 sine theta x cap. That is what you are going to get. So after getting that, you have to subtract that also y0 what was that, y0 um, minus minus 4y cap, right? So you have to subtract that from that. So you have to, all you have to do is just subtract 4 minus 4 3x cap 3x cap minus 4y cap. So if you do that with this along with that, all that you have to do is that, and you get the new matrix. Okay, this is the result. So for this matrix, for this value of a vector transformed into x and y, in terms of x and y from j and l, the result will be this combined 3 cos theta x cap, all this combined with the, you have to subtract a 3x and minus 4y, because your new uh, coordinate has also transformed, shifted in an angle, right? Where was that plot? Shifted in an angle. Okay, it was shifted in an angle. So this angle and the distance has to be considered. So with that, I'm going to close in, and I believe that you have understood this very well. It's a very important part. You can use the rotation metrics in all aspects of calculations that you have, and I wish you well, good luck. Okay.